To realize your great app idea, right, you need very good tools. Very importantly, very good UI framework, UI tools, isn't it? Right. So, what are these UI frameworks basic requirements you would expect really? It should have very rich feature set, right? It should be very easy to use, whether it's API level or with UI builder. It should be very lightweight and performance should be much better. And along with that, feature wise, not only meeting the current trend, it should be feature proof also very much. So you cannot change your application after 1 year, there is a new trend is coming, you have to learn new framework and bring it in. No, right? You need the current framework should feature proof. Considering all these aspects, we have included 2 UI framework, native UI framework as part of Tizen, EFL and DALI. Okay, so the key takeaway from this session will be understanding the basics of EFL and DALI and their feature set, basic features, advanced feature set, and demo application, sample application, how you can write it, right, and some demos. We are introducing 2 UI frameworks, right? So you might be having some confusion. Which one I should choose, right? Or what kind of requirement? So end of the session, we'll give some guideline, right, to choose the right framework for your need. So let's start with the Tizen native UI framework architecture part. So we have covered in many sessions. Tizen is based on the Linux kernel. And we have 2 important UI frameworks, EFL and DALI. In addition, we have a Cairo, that's a 2D rendering part, 2D rendering library, and OpenGLE's library, it's for your 3D rendering, it's also open as part of Tizen UI framework. And we have other important subsystems. One is X11, it's a windowing system which really interacts with your hardware, right, to display the final buffer to the hardware driver and receives the events and gives to your application higher level. Right. So the X11 also provides the buffer windowing for your the higher levels. And if you have multiple windows, so like you have multiple applications, a single application having multiple windows, so it should be stacking order should be maintained and it should be composited to make it as a single layer to give it to the display. Right. So then some module should do what? The E17, that's EFL based, again it's EFL based module, E17 is used, that's a window manager compositor. There are other modules, interesting modules, there are some questions in the previous sessions also like speech to text or text to speech, etc. So the Tizen UI framework has ISF, input service framework, it includes that, which facilitates to create the soft keypad. So all the input related things, you can create a soft keypad. You can have your voice recognition engine or your text to speech engine integrated with that. And we have other things like a font engine, etc. Let's get into these 2 UI frameworks, EFL and DALI in detail. Right. EFL, Enlightenment Foundation Libraries, right? It's an open source project. It is 2D 2.5D framework. Right? So why 2.5D? It provides set of 2D animations, effects, UI development as well as 3D environment. You can have a set of 3D effects also, it's possible. So that's why we call 2.5D. EFL can run on purely on software, or you can have hardware accelerated. It runs on OpenGL also. The specialty of EFL is it splits your functionality and the GUI logic, how they should look and feel, everything. Actually, we have the EFL founder, the open source founder is with us. Just Raster, the Carsten Heichler is with us. Want to say hi quickly?
Hi. You can ask me questions later. I'm actually taking over Ash's session at 5:30.
Yeah.
couldn't make it. So if
Yeah.
you've got questions, ask me then. Otherwise, we'll continue now.
Thank you. So DALI, it's a Tizen homegrown UI framework. It's a 3D scene graph based UI rendering engine. Right? So it's completely on top of OpenGL ES. So it utilizes the OpenGL ES heavily. It provides the shaders, textures based animations, etc. You can also create 2D UI with G-plane with 0 level, 1 level. Very much possible. Okay, so let's jump into the EFL in detail. Enlightenment Foundation Libraries, EFL. Right. So EFL, as per the name, right, it's not single library, it's set of libraries. Right. So many libraries you can find out here. In that, like, we are going to discuss about 5 important libraries. INO, eCore, Evas, Edge, Elementary. What are these names? All are E'd, starting with E. Right. So the Enlightenment open source project, the foundation, they have the naming convention starting all the libraries with E. That's a specialty. Maybe all the libraries are enlightened. Start with Evas part. It's a canvas library. Right. So what is this canvas? So if you want to render something or draw something in your real life, you want to draw something, you need a board or you need a wall, and you will have maybe stencils to draw the basic drawings, the fixed drawings. You will have a brushes, etc. Your things. Right? You can draw it either with stencil, fixed set of drawings. You can do it, or with a freehand drawing. You can do with the brushes. Right? It's the canvas things. Equate that in the computer term. Evas is equivalent to that. It is a stateful canvas library. The specialty is Evas can run it on software as well as GL. So what does that mean? Evas really focuses or exposes API only on what you want to do it, not on how part. Right? You need not worry about like how I can just render something, how I can just create this object, image loading, all those things. Why have to, as an application developer, why you have to worry all those things? Abstract everything. Evas does that one. So you just focus on what you want to do it, what you want to get displayed. The remaining everything is taken care by Evas internally. I want to introduce this Evas scene graph part first. Right? So what is scene graph? You have hierarchical objects. If you have a UI, right, your screen, you'll have many number of objects. Right? So each object will have its own properties. Right, like it can be a size, location, color, font. It can be a number of custom properties also. So the scene graph maintains such properties. Then hierarchy order. Importantly, it maintains how to render, draw those objects internally. It can be rendered using pure software engine or can be a GL engine. That's totally abstracted internally. So you can just focus on what you want to draw, just create your object, started. The rendering will be taken care internally by Evas part. Let's look at this sample example. See, right? So you have set of rectangles and the cloud image, etc. The second image, it moves down, right? Right. So there is a change in the animation, the location change, property change, because Evas maintains the state of each object and it knows how to render it. And you can do very, very optimal rendering of finding out, okay, because of this change, what need to be re-rendered. Only minimal part, right? That the third diagram, right? Third image. So it just re-renders only that part, well optimized. So it's very lightweight, well optimized. So we are getting a much better performance. This is the main success story reason for G1. All our native applications are EFL applications. Much better performance in even low-end hardwares. Another important keyword I want to introduce here, EFL follows retain mode rendering architecture. What is that? If you are creating your application and if you are creating all application UI elements, objects, right? So that is not rendered immediately. Because Evas has the logic how to render it, but it will not render immediately. It just maintains the scene model. Okay, these are the changes, object creation or property changes is invoked by the user. I'll just keep track of it. It keeps it, and it decides when those changes should be realized, rendered at later stage, well optimized way. Right. So it simplifies a lot of things, and it also helps to achieve the best performance out of all those things. You need the best performance, the UI application, right? Very smooth, silky smoothness. It's getting achieved by this architecture model. So Evas exposes set of primitive objects because it has its own rendering mechanism. That means obviously it should expose set of objects, right? Useful set of basic and advanced set of objects. So these are the basic set of objects. You have rectangle, image, text, the text block, that can be the recently added vector graphics object. You want to have an object, but like that content should be from your vector graphics content. We have the object over here, and we have smart objects. Smart objects can be your containers. You want to include many objects put together in different ways, a box, right, grid, table, etc. I can be some more custom objects. All the UI controls, right, button or anything, everything is a smart object. So all these objects are defined. It knows how to render it internally. Rendering means it can be loading a font, loading an image, right, placing it in right format, layout, everything includes. Let's look into some of the advanced features of Evas. Evas map. It provides 3D transformation. What is the speciality about 3D transformation as part of UI framework? This is possible even on top of software, irrespective of the engine you are choosing it, whether it's a software engine or GL engine. Your functionality is intact, it's available. Right? So some of the low-end hardware, right? Not only the mobile, low-end hardware may not be having a GPU. Still, all the effects you can achieve it in the software base with better performance. That's the specialty of EFL. Evas VG, we saw that vector graphics part. You can have a vector graphics rendering as part of your project. Let's move to the next library, INO. So INO provides efficient implementation of your data structures. Yes. So can be a list, array, a simple data structures. There's a complex one. So it can be arbitrary, right? A string share. Your application generally may be having a same string, right? In many places you'll be using it all repeated, many places different memory allocation. So you can have one single location, memory allocation of such strings and refer it in all the possible places. String share, it helps to you to achieve that one. And there are utility functions like the INA benchmark. If you want to benchmark your application and do it, it provides that benchmark utility. Logging facility, right? Mempool. Instead of every time allocating a memory from system, you can have a mempool and reuse the memory much efficient way. And the module, dynamic SO loading or your plugin loading. If you have an application with plugins, you can load it. There's a simple wrap utility is provided by INO. Next part is eCore, the main control thing. Any UI framework, the basic thing is, right, you need a one main loop control loop. It's provided by the eCore, which delivers the event. Can be key event, touch event, like timer event, or any sensor events like rotation, etc. It's getting delivered through your main event loop. Right. So this event loop, delivering all these events to your application, gives the controls to your application. Application does some job based on all your events, and it does some state change. Okay, I want to redo this, right? I want to give some effect and place a new object here in my screen or change my screen. And then that state changes taken care by Evas, and then it renders it, and that push it to display through X11. It's getting displayed. All those things happens in very short period. What is that short period? Right. So we need better performance means what is a better performance? We need 60 FPS. Many of you might have heard about the 60 frame per second. What is that? Our human brain and eye can identify 60 distinct frames. When something is moving, you can just see that. If it is more than 60, you cannot observe it. But less than 50, if there is no reference point, still it's okay. So like video and all can be 25 FPS, 30 FPS, it's fine because there is no reference point, your brain accepts it. But if you are having an application with some finger following, that means finger is moving, it can identify 60 different movements. But if your UI is moving less than that, you can say, hey, your UI is slow. Right? So that we have to really optimize, make a better view application. So EFL already optimized, Xcloud already optimized, we have that, but application level you have to take care to achieve that end-to-end. So that means like in 16.7 milliseconds, the end-to-end, you have to generate a new frame. In that way, you can just achieve a better performance. Can be up to 50 to 60 FPS, it's acceptable. Try to achieve that one when you are developing applications. That means you have to take a few things. Heavy task, you should not do it in the main thread, and you have to offload it. If it is totally heavy thread, use the thread, eCore thread, and use the eCore pipe for communicating between main thread and your worker thread. If it is moderately heavy task, use the eCore job. And you have timers, and there's audio and IMF part. If you want to do some audio feedback from your UI based on some user action, you can use this API set. IMF is mainly the input service framework wrapper on EFL side to launch your sub keypad or voice recognition engine, etc. Let's move to the next library part, Edge. Edge is the graphical GUI designer library. Right? So there is the Edge library, so which loads the script, something called EDC, Edge Data Collection. It's a two-part, Edge library and EDC file. We have seen a few reference of EDC in the previous session. So the EDC file, you will be defining all your GUI layouts, animations, the themes, everything, and then it can be compiled. It's compiler, so it bundles all the layout parts. Maybe you are having a lot of images as part of it, things. Bundles that, maybe sound also, etc. It bundles everything, makes that a single EDG bundle, and you have C application, your application part, and which can load it and display according to that. You have business logic in C code, and EDC has all the layouts, look and feel, everything. So it's completely separate. So you can have your GUI layout development independent of your C code, and you can replace that EDC bundle. So you will have a different, different look and feel. We'll see that like advanced, basic examples, advanced examples. We have it in the further slides. Scalable UI. There was a question in the previous session. Scalability is very important requirement for Tizen applications because Tizen supports multiple different type of profiles. We have a TV profile, we have a mobile profile, we have a gears, wearable, and we have a camera. There are a lot many upcoming refrigerator, right, washing machine, etc. How to cater into all this category when you are developing your application? It should be able to run at least most of things, if not for all. You should be able to do it. That means you should be able to develop, while developing itself, you have to take care certain things. So that will really help to directly run your application on other type of devices also. So the aspect ratio can be different. For example, TV 4:3, but mobile can be 3:4. Right? The portrait mode, it can be a smaller screen. Your resolution can be different. Aspect ratio can be different. Your dots per inch of your screen can be different. Maybe low and high end device. When you are touching your finger, if it is low DPI, you will be touching very few pixels. But if it is high DPI, dots per inch device, like very high end, like we have. So when you're touching it, you'll be touching more pixels. That means your UI layout should be designed according to that. It should be easily touchable. You should not try to, okay, many times, then only it takes the event. So all those things really the EFL takes care of it. But when you're doing a custom layout theme in your application, you have to take care. So that will help these things to take into different type of devices. So how we can achieve this? If you start hard coding the screen value when you're developing application, it's not possible. So EFL and Edge, it defines with 0 to 1. whatever your screen size, right? It's top left is 0, 0, bottom right is 1. Everything is this coordinate. Beyond this, beyond 1, it's either outside, right, bottom, left, top, your area. You can place your objects, but that's outside rendering area. Any animation, you can move it out from -1 to 0. It comes from inside, possible. But within screen area, it's 0 to 1. Let's say one sample EDC file. So EDC is your layout part, right? So you can have many parts, objects. So it can have many, each part can have different properties. Right? So one example we are seeing is the image object, which one property, the location. So 0.1 to 0.3, X and Y location. So the variation is 0.2. And I'm also defining one more state. We can change the state, right? Object. State with a different location, 0.9 to 1 at 0. Notice this, here the difference is 0.2, here 0.1, right? So if I show this image, ball.bng, which is loaded, so one first state it will display in the topmost, and the second state if I change it, it will come to the bottom. I can add some more dynamic animations. So we have EDC programs. It's mainly to handle all your signals, events, signals, etc. in the layout side also. It provides more dynamic things. So in this program, I just added state set, moving the state 1 to other state with transition. Move from this state to this state, but not immediately, just next frame. Do it in 0.5 second and in accelerate mode. Start from slow to fast, and just repeatedly running these programs. Second one, from bottom, you move to the again top. But here now, accelerate. What does that mean? It's opposite way, but do it in 1 second. Right? State change happens, but like it's in steps. All these intermediate steps, it's taken care by Edge EFL. Let's see how this output looks. Demo, please. That's it. So you are defining a object to state, and you have a program is saying it like you set the state, right, in this time frame, all intermediate frames. 1 second please, and you can see that same demo. 1 second please. You can see that ball size big to small because the difference 0.2, 0.2 to 0.1, 0.1. Smoothly it scales and displays it. Everything is taken care internally by EFL. Amazing, right? Okay, let's get into the other elementary, the next set of widgets. Widget set library. So this provides a very high level controls. You can create your UI using this extensive set of UI controls. I want to mention about few things. The window, your canvas layer, and then conformant. It's really required for your auto scroll. Your UI is abstracted by some soft keypad or indicator. You should provide option for your user to access your UI in the remaining area, right? It should be constrained, auto scroll, everything. That's provided by conformant. You need not do anything. EFL has that support. So just add the conformant to the window and add your layout to the conformant. Automatically takes care. Elementary, the WinSet library, widget set library. It also provides I18 and localization part, right? Translation, or you can RTL, right to left. So like if you want to take your application beyond India, right? So other RTL countries mirroring support, it already supports it. And the theming functionality, with changing EDC, you can have different look and feel, animations, effects, etc. It's possible. It's very powerful. So we saw that like there's a C code, there's a EDC, there are here and there. Right? How to really put together? You should get some idea. Right? So EDC is a script file. Right? So it's getting loaded at runtime by Edge library, and it creates the object hierarchy, Evas object hierarchy. That's a basic. Right? So if you have that, if you want to have some signaling between your actual C code, application code, and this, it's possible there are signals and messages available. Right? So let's see like how to really load it first. Right? Just create a elementary layout and then set layout. Right? Layout file set. So this one will load that EDJ, will create all the set of hierarchy of objects. The next part is the signaling between EDC and C. So compiled version, EDC compiled version output is EDJ. Yes. So we have the program, it's listening for test part hidden signal. It's getting generated in your C code. You just raise the signal from your C code. Same way the other way. Your program can raise a signal on mouse click. On mouse click, it comes to your C program, and you can raise a click signal and register callback. It will get triggered. Let's see like how to really in your application how to load this, link these two. It's a basic EFL application. So you create your window, your canvas part, and create a layout, load your EDJ part. So you have a layout ready. We saw the EDC with the image, but instead of image, if I have a placeholder, I can place anything whichever I want. Right? It is something like you have a meeting room. I can have a table with a round arrangement. Right? That's a EDC. I have round arrangement chairs, and with the chairs as your placeholders. My application decides who to sit over there, each place. Right? So the application only decides persons and logic and everything, but the placing, the sitting arrangements taken by someone else. You can have a different type of meeting room with different grid arrangement. You can go and sit it, or like without naming, just anywhere you can go and sit it. All is possible. So that's what EDC, your layout part. So we are calling this placeholder called swallow. Swallow it into that. So we are naming the placeholder some name, part swallow, and I'm creating a button object there, coming to that simple application, and button is swallowed into the part swallow, and then run this application. Right. So this is my EDC layout. I just slightly modified. Instead of image, I replaced with swallow. Same as the animation part is there. If there is no animation, no program, it just goes and swallows and sits over there. No change, no animation, nothing. Just to demonstrate to you, we added the program also, right, to make it more fun. So let's see that like say this is the placeholder. It has same location, one place to other place, and instead of bar, we are creating a button in C application and following over here. Let's see how it looks. Demo, please. Same one. I'm clicking the button while capturing the video. You can see that the button is followed in that. So like that, you can create any complex layout using EDC and create your basic objects from C code. Swallow it, push it over there. That's simple. Is it that much? EDC is that much? No. Let's add some more effects. Right? The same swallow part. Right? So we saw that the map, Evas map, which is 3D transformation. We can do that. Let's apply the 3D transformation things to the same swallow part. I don't know what object is coming in from C code dynamically, but I can apply this effects. So I'm adding a perspective map. It's a Y angle 0 and 1 state, other state 360 degree, and again animating it. Right. See how it looks. Video please. Full rotation with all intermediate state 0 to 360 degree. It takes care, EFL takes care of. So that is the real strength of EFL. So it's very lightweight and feature rich. You can create a very exciting UI using all these feature set. Yes. So theme, you can have one set of EDC and you get simple effect. You can have another set of EDC with advanced effects. You can monetize the themes also as part of your application. So look at that one complex example. We have dialer application with normal grid with one EDC. That one EDC part, we made one more EDC, replaced it with a round dialer with the older phones. It is not just fixed one, right? We made like it's possible, you can just fully round it. Full effects, very much possible with EFL EDC. We have the working demo. And not only the UI effects, you can also generate a sound when you are doing it as part of EDC. I mean, there's such a sound not recorded in the grid layout, but here it's required. You can generate a vibration, all part of EDC. You can have it, replace the bundle, you will get amazing effect for your application. Priority. So we have the default priorities, the platform, the product themes, and you can have extensions, which are low priority than the default themes, and the overlays, they are the high priority. If you want to override some of the default style, you can use the overlays. We saw that set of primitive objects or the small objects, but if I want to do some custom rendering, I want to do some custom thing, I want to get it displayed. Is that possible with EFL? Very much. The EFL image, Evas image comes into handy for this. So take the image buffer, get it rendered with your 2D library like Cairo or 3D, and push it as image. Simple. So you can have a custom rendering also. It's possible, very much possible as part of EFL. Okay, so that's the end of EFL session. We'll move it to the DALI part. So DALI is a dynamic animation library. It's a Tizen homegrown 3D UI framework. So DALI concept itself, it's completely on 3D plane. And the camera position always looks into the -G, that means for. Why do we need really this one more UI framework, DALI? What is the need? Let's see the demo. What are the special effects really we can get it as part of DALI? Then let's see whether it's interesting one or not. Demo, please. Transition effects. Page turn effect, your ebook. Just apply simple text shader, you can get this. Dissolve effect. Scroll effect. Depth view, scroll effect again. Spiral effect is very nice, right? This scroll effect again. Soft button effect, the real soft button touch effect. Metal UI, gold UI, the lights. So such a great 3D effects, you can achieve it very simply with DALI. That's the power of DALI. The DALI architecture, there are three main parts. One is DALI core, which does the 3D model import, support, rendering, layout, animations, scene graph, event handling, etc. DALI toolkit, which provides the high-level UI controls, easy to use UI controls for your applications, and then shaders effects. And third part is the platform porting part. One is the actual platform porting on Tizen, because you might have heard in the keynote session, this DALI is available in Android also S6 effects. So yeah, so that's internal, not opened up. And if you want to have this such a DALI effects on EFL or web, we have our plugins. And DALI also depends on many other external libraries like font libraries, image loading, or model import as that import library, etc. So let's look into the DALI basics. So DALI is totally a new concept. You have to think in that in a different way. Right? It's in the 3D space. So it's again 3D scene graph based. We saw that EFL also scene graph based, DALI also scene graph based UI framework, and the stage defines the 3D world for me, and actor, assume me as an actor, is all objects, UI objects. So the actor can take events and react to that. So in UI you'll have a stage and you'll have an actor. Actor will receive events. Actor can be different type of actors. We'll see that further slides. And you can have a lot of effects for the actors, right? Different effects. While rendering it or actual designing it, you can have different effects. Right? The shaders will be helpful to achieve such effects. And 3D models, you can import it. That will help for your rapid UI development, 3D model support. DALI actors. This is the basic building blocks of DALI. So we have like image actor, load image, you can create a UI. Text actor, model actor to import your model. Camera actor, which is your eye position or camera position, right? To change that one, to give a different view. Camera actor, light actor. From where the light is. So you saw that metal UI with light effects. So there are not many actors available as part of DALI, and you can also create many custom actors. Constraints. This is very important. If you want to have a very exciting animations, effects, you might have heard about the physics engine. How the real physics world, something is hitting, things are moving it. So that's mainly like the maths. So depending on set of objects properties, you decide on another property and then do some action effects. So the constraint resolver and property notification support is inbuilt as part of DALI. That will be very much helpful to you to create a new set of properties based on set of other properties. In the example, for example, if you have a paddle, you have a ball, based on the ball size and location, paddle size and location, you can decide whether it's in collision or not. Based on the collision, you can generate set of effects. So, animations. So, there are different type of animations possible. It can be a property animation. Changing a location is one animation, right? From starting position to ending position, we saw that in EDC. So, such animations based on the property change is possible. Vertex and mesh animation, shader uniform animation, and the model. If you are importing a model, you can have a bone or joint animations, you can have it. Very rich animations is possible with DALI. Shader effects. Each actor has its own default shaders, but you can override. So it can be a geometry or pixel, right? Shaders, you can override that. So you can see that lot of default or inbuilt shaders available. Can be a mirroring, wedge tone, can be a dissolve, can be a water, a ripple, not many. Just few samples here. You can just apply on any of your objects. 3D models, you can import it, like Collada, 3D Max, Maya, and even DALI has its own 3D model. It's very efficient one. You can import it, you can have a UI development based on your 3D models. And open asset import library is used to import the models. UI controls, it's a high level actors, you can say that. It enhances with the layouting, better layouting. For example, a button, you pop up with the layout part, or the scrollability, you have a scroller item view, right? Such an enhancement it provides on top of the basic actors. So these are the few sample UI controls, DALI UI controls. So let's look into that, how to really develop a DALI application. We saw that like actor is important UI element which can take a event, display, etc. So create a image actor. I'm just showing it, for example. Create an image file with properties, create an image actor, and add to the stage. Adding to the stage, activating it. It's away from stage, it's not activated. That's it. So the concept is so add your image actor to the stage. His actor is getting displayed. So in addition, DALI provides a wrapper on top of this basic EFL core APIs like application and event loop, etc. It's a main loop. It's a wrapper on top of DALI. So that was the end of DALI introduction or the feature set introductions. So we understood all the feature set, how to develop application, how to link EFL, EDC, EFL application development, demos, DALI basic application development, and the concepts. Both EFL and DALI, they have their own UI builders. So you can do the rapid UI development using those UI builders. Okay, now the difficult part. Which one to choose? What is the specialty of each one, and which one you have to choose it for what kind of application requirement? If you are developing some great application that should have very good performance, lightweight, right? But effect wise, you need up to 2D, 2.5D, which we saw as part of EFL, and it can run on software also, or GL if it is available, GL acceleration. Otherwise, it's okay. That kind of situation, go for EFL. It's the best tool. You need very rich 3D effects, 3D model importing, etc. Right? Physics effects, etc. Go for DALI. Both are powerful tools, but you have to judicially choose any one of these tools based on your requirement. Okay, let's take that's all about this EFL DALI session. I'll take a few QA questions. So the question is about if I want to get some of the DALI effects, but I want to develop a EFL application. So we can achieve as much, most of these DALI effects also, like it's a very basic thing, you can do it in EFL very much. But still, if you want to have some of the DALI effects, we have a EFL adapter. DALI has a EFL adapter, so DALI can render that, and finally the rendered image can be given to the EFL. The EFL just displays as the buffer. It's possible. Mike.
Hello. Yep. I just wanted to know whether there is a replacement for view pager, kind of what we have in Android. Just wanted to know whether that replacement is there. Slider or view pager.
You are talking about set of controls, right?
Yes,
which is
widgets.
available.
When I speak about the widgets and all, initially when you started off, widgets were there. I just wanted to know whether those sort of widgets are there or not.
Yes, it's there.
View pager or sliders.
Yes,
kind of.
very much it's there.
Because I didn't see those kind of things, or the fragments, what comes up in Android. UI fragments.
Fragments, you want to separate it out, the divider kind of things?
Not divider, it's like sort of like UI placeholders.
So, of course, so that's what the swallow part we saw, that the placeholder, you can just create any UI and place it. It's there. So, there are different type of placeholders. You can we can discuss it. Only like placing a simple objects, or like I can have a full pages right, and the animation.
Full set
you can
of
have it.
pages.
So we have something called navigation bar. So you can have multiple pages, you can navigate it. So very much part of EFL. It's available.
Do you have any UI builder for DALI and EFL?
Yes. In the previous session, you might have seen the inventor. That's a EFL UI builder. DALI also has its own separate UI builder. We have very good documentation in Tizen.org. You can get all the information. Maybe just a quick talk you want to hear from the EFL founder, Rasta?
I
Rasta?
have to do a presentation next door in 5 minutes, so.
Okay, sorry, he's having another presentation. Maybe you can catch up in another one.
Yeah. So finish the questions.
Yeah. Any more questions? Thank you.